Okay, so we see now in detail about the chemical properties of methane and ethane. Now we learned that because methane and ethane, or basically alkanes, are saturated hydrocarbons, so the only possible reaction over here is a substitution reaction or displacement reaction. The only thing what can have is substitution. So depending upon what is going to be what the hydrogen is going to be substituted by, the substitution reaction is the only type of reaction. So if the hydrogen is substituted by halogen, it will be halogenation, and so on. So we will be just seeing those. So basically what we are going to do is the different kind of substitution which can take place in case of an alkane. So first is, when you take a methane and you have got chlorine which is going to be reacting, so that is called as chlorination. So the first one is chlorination. Now in chlorination, also called as halogenation, because all halogens will be having this same property. So accordingly, what we'll be having is CH4 plus Cl2 is going to give you, the first thing what it gives you is CH3Cl plus HCl. So this is the reaction which is going to be the thing, and this is going to be conducted in diffused sunlight. So it will be in diffused sunlight and heat or heat, so both will be there. Now this is not going to end here. What is going to happen is it's going to be a continuous process till the time the chlorine is available to it. So this again, now what will happen is this CH3Cl will again react with Cl2 to give you another CH2Cl2 plus HCl. Okay. Now, so this was monochloromethane. Okay. Now this is going to be equal to dichloromethane. Okay. So अभी डाइक्लोरो है, अभी तीसरा. So this dichloroethane CH2Cl2 will react with Cl2 again to give you CHCl3, which will be trichloroethane. Now trichloroethane is also called as chloroform. The chloroform which is used normally for anesthesia, or basically to make somebody faint somebody, तो वो जो है, that is chloroform, which is CHCl3, that is trichloromethane. So trichloromethane is this one, plus HCl is going to be there, and finally it is going to be complete the substitution. So CH3Cl3 plus Cl2 will finally give me CCl4, which is carbon tetrachloride plus HCl. So this is the final reaction. So this reaction is going to take place in 4 steps. So we see the chlorination, substitution of the hydrogen atoms of methane by chlorine atoms. Condition required is the diffused sunlight, ultraviolet light, or high temperature up to 400 degrees Celsius. Substitution products will be, first is monochloromethane, then it will be dichloromethane, then trichloromethane, which is nothing but chloroform, and fourth will be carbon tetrachloride, or it is tetrachloromethane, that is carbon tetrachloride. Same thing can also happen in case of ethane. अभी यही चीज है. So you can see the first reaction will be this way, that C2H6 plus Cl2 will give you, with the same conditions, it will give you C2H5Cl plus HCl. And finally, after 6 reactions, it is going to be C2H6 plus Cl2. Sorry, this will become, by that time it will be C2HCl5 plus Cl2 will give you C2Cl6 plus HCl. So this is how you are going to have the substitution taking place one by one, step by step. So first will be monochloroethane, then will be dichloroethane, then trichloroethane, tetrachloroethane, then pentachloroethane. Okay, and finally it will be hexachloroethane. So in this way, the ethane is going to get substituted by chlorine and going to form into finally tetrachloroethane. Your methane is going to become methane. So this is how the product can be separated by fractional distillation due to difference in the boiling point. So this too can be separated by the distillation because of by boiling point being different. So this was the first and the foremost kind of substitution. The next most important reaction is that this reaction will always be there in any kind of hydrocarbon you are studying. So that reaction is oxidation, because we know that all the hydrocarbons are very good fuel. So because they are very good fuel, so they can be burned in air. So the next one is oxidation reaction. So in oxidation reaction, we can just say the first thing as CH4 plus O2 in excess, which is going to give you as CO2 plus H2O plus heat. So the balancing is just this way. So C2H4 plus 2, now this is going to be in excess. Only then it is going to give you CO2, otherwise give you CO. So that is the case. In case of C2H6, there will be 7O2 plus, it will give you CO2 plus H2O. So that will be 4 CO2 plus 6 H2O plus heat. So this is the condition for it to be complete oxidation of methane or ethane takes place. When complete oxidation of methane or ethane takes place, that is in presence of excess of oxygen, then it is going to form into carbon dioxide and water. So whenever any hydrocarbon is heated, remember this thing, whenever any hydrocarbon is heated, you are going to get the end result as carbon dioxide and water. See this, wax को भी हम लोग heat करेंगे तो you get carbon dioxide and water. Okay, so any hydrocarbon when it is heated, it is going to give you carbon dioxide and water. So conditions is that in excess of air, methane or ethane burns with a blue non-luminous flame. तुम लोग ने देखा रहेगा, तुम लोग का जो गैस है घर में जो गैस होता है, it is not illuminating, it is just non-illuminating, it's a blue color non-illuminating kind of a flame. So that is the same as methane or ethane burning. So product is CO2 and water. If this particular reaction is taking place not in excess of oxygen but less amount of oxygen is there, in that case, in limited amount of oxygen, what will happen will be, this will be CH4 plus limited amount of oxygen, that is we are taking it as 3 with limited amount, and this will give you as 2CO plus 4H2O, so plus heat. So this will give you carbon monoxide. Okay, so that is going to be when it is carbon monoxide. And also if it is very limited, so the same way it can also be C2H6 plus 5O2, which is a limited quantity, will give us 4CO plus 6H2O plus heat. If this is less than this, so if it limited के बदले very limited quantity अगर हुआ तो C2H6 plus 3O2, that is very limited amount of oxygen, will give you C, that is 4C plus 6H2O. So this is, it is going to give you carbon black. So if the burning of the hydrocarbon is taking place with less amount of oxygen, then it is going to give rise to the condition. One sec, I'll just balance this equations. Yeah. So you can see that in case of incomplete oxidation, it gives you carbon monoxide. So carbon monoxide is going to be the end product when the amount of oxygen is less. You can see here with one atom there were 2 oxygen atoms, whereas molecules, whereas with 2 it is having only 3. That means it is less amount of quantity over here. Here 2 के साथ 7 था, यहाँ पे 2 के साथ 5 है, यहाँ पे 3 है. So as the oxygen content keeps on decreasing, the oxidation is going to be not complete, and due to incomplete oxidation, what you are going to get is, first is carbon dioxide with complete oxidation, incomplete oxidation CO, carbon monoxide, and with very limited, so less amount of oxidation will be only carbon, that is carbon black. So limited or air or oxygen, the in limited carbon monoxide and water, and in very limited carbon black and water will be formed. The next one we see is the catalytic oxidation of methane and ethane to give you alcohols, aldehydes and acids depending on the reaction condition. So depending on the reaction conditions, the alkane is going to get converted into alcohols, aldehydes and carboxylic acid. So that's what we are going to see now. And this particular process of converting the alkanes into alcohols, aldehydes and the acids can also take place by slow oxidation reaction. So basically what we are trying to do is that in a methane or ethane, we are adding some oxygen content to it so that it becomes OH or HO, CHO or COOH. So that is how it is working. So first thing is the methane converted into alcohol. So first is CH4. It is going to react with O2. So that is going to react to give you CH3COH. That is the balancing over here. This is under Cu tubes. So Cu tube and 200 degrees Celsius. Okay. Similarly, if you take a C2H6, then plus O2 will give you the same thing with Cu tube at 200 degrees Celsius as 2C2H5OH. So this is methanol. This is ethanol. So CH2 or C2H6, CH4 or C2H6 and air pass in a ratio of 9:1 by volume through a catalyst copper tubes at a temperature 200 degrees Celsius and atmosphere 100 atmosphere pressure. It is going to give you alcohol. So this is how you are going to get an alcohol from the methane with Cu tubes. Further, if you use the same thing again, so if this thing process is further going to be used up, then what will happen? It will be CH3OH will be reacting with O2 in the same conditions over here, Cu tubes and 200 degrees Celsius will automatically give you over here 2HCHO. That is nothing but methanol. What is it? Acetyl. Okay. Aldehyde, sorry, it is aldehyde. That is why it is going to be giving you as this much. And further, if I am going to take this one, that is CHCHO, if I react with O2 with the same condition of Cu tubes and 200 degrees Celsius and 100 atmosphere pressure, you are going to get over here as CH2HCOOH. So this is going to be there. Here you are going to get also water plus water, but here you are going to directly get over here as alcohol. This is carbolic acid. So this is methanoic acid. This is methanoic acid, HCOH. Okay. So you can see that first of all, the alkane, it got converted into an alcohol. The alcohol got converted into aldehyde and the aldehyde became carboxylic acid. So this is the chain which is taking place. Alkanes, oxidation हुआ copper tube के साथ में, it gave you an alcohol. Alcohol copper tube के साथ में react हुआ, methane मिला, that is an aldehyde. Aldehyde react with oxygen to give you methanoic acid, that is carboxylic acid. So this is the reaction which is going to take place with copper as the catalyst. Now the same thing, if the copper ke badle, if I am having molybdenum oxide as the catalyst, so if the same thing process over here is such that I am using over here CH4 and O2, but I am using molybdenum oxide as a catalyst at 350 to 500 degrees Celsius, then I am going to get over here as HCHO, that is an aldehyde directly, that is methanol plus water. So this is the, यहाँ से हम लोग को सीधा ये मिलता है. Okay, from here you are going to get directly this one if you are not using copper but you are using molybdenum oxide. Okay, that is what is given over here. So same way, if you are using ethane, it will give you ethanol with the same kind of reactions. So CH4 or C2H6 with air in presence of molybdenum oxide is going at 350 to 500 degrees Celsius is going to give you an aldehyde directly. So this is the reaction. So if you are using copper tubes, then you are going to have alkane to alcohol, alcohol to aldehyde, alcohol to carboxylic acid. But if you are using molybdenum oxide, the alkane directly jumps to aldehydes. You can also have the whole process done with the help of a slow oxidation process. So in a slow oxidation process, what happens is that CH4 is going to be processed in the presence of oxygen, nascent oxygen and K2Cr2O7, that is potassium dichromate you are going to get first is the CH3OH, that is an alcohol. So alkane to alcohol, so you can say alkane to alcohol. The next one is alcohol is going to be reacting again with the same conditions with K2Cr2O7, will give you an aldehyde, that is going to give you as HCHO, that will be aldehyde, and HCHO again when it reacts with O and it is going to react K2Cr2O7, it is going to give you as HCOOH, which is the methanoic acid, that is oxalic acid. Same thing for methane के पहले ethane का भी वही होगा, ethane का ethanol, ethanol so ethanal, ethanal to ethanoic acid. Methane ka methanol, methanol to methanol, methanol to methanoic acid. So in this way, this particular process over here is called as slow oxidation. So in a slow oxidation process, the process goes from alkanes to carboxylic acid without changing any particular thing. Only you are having is the nascent oxygen, which is alkanes with controlled oxidation with oxidizing agent K2Cr2O7. Pressure is high and temperature is low. That is acidified. K2Cr2O7 is acidified with sulfuric acid, dilute sulfuric acid. So gives you the corresponding alcohol, which further oxidizes to give you corresponding aldehyde and then the corresponding acid. So this way it is going to give you this way. And the same thing in presence of oxidizing agent, that is K2Cr2O7, it is going to give you the same formula CH3CO but O. So the reactions which are here for this one is similar to this one, that you are going to have it as CH3COH plus O giving you HCHO plus H2O. So that was about the controlled slow slow oxidation reaction. The next over here is going to be called as pyrolysis. Now pyrolysis is a kind of the thing wherein you are converting an alkane into an alkene or alkyne. That means you are converting a saturated hydrocarbon into an unsaturated hydrocarbon. So that is called as pyrolysis. So when there is the fusion of an alkane with another alkane at very high temperatures, they are going to be converted into what we say is the hydrogen gas will be released and there will be double bond or triple bond formed between them. This process is called as pyrolysis. So that is, the condition is pyrolysis. So pyrolysis is the method in which 2CH4 on heating at a temperature of 1500 degrees Celsius, so very high temperature, it is going to get converted into HC double bond C. So it is going to get, triple bond. So it is going to convert into ethine. Okay, this is going to get converted into ethine plus hydrogen gas is going to be released. So hydrogen over here, so balancing it to 3. So that's what is pyrolysis in this case. If you are taking over here ethane, that is H3C single bond CH3, and you are reacting with same thing 500 degrees Celsius, but catalyst over here is Al2O3. In that case, it is going to become H2C double bond CH2 plus H2. So this is going to be ethene. So ethane will give you ethene, and methane is going to give you ethine at very high temperature. So conditions: thermal or catalytic decomposition of alkanes in absence of air at high temperature is called pyrolysis. Catalytic cracking in a dehydrogenation reaction. Dehydrogenation reaction क्यों बोलते हैं? Because hydrogen is removed from that particular alkane. So because hydrogen is removed, that's why it is called as dehydrogenation. All these words, dehydrogenation, decalcification, they are very important because they will ask you questions also. They can ask you questions like that give the dehydrogenation reaction of methane. So then you will have to show this particular thing, which is pyrolysis. So that is how you see the reactions. Next is the uses, methane and ethane. So first is illuminant and domestic fuel. In the form of natural gas or gobar gas, that is hydrocarbons have high calorific value, they are easily combustible and the reaction is exothermic, hence release heat energy, hence they are excellent fuels. So hydrocarbons, they are very excellent, very good fuels because they are able to give a lot of amount, they have got a good calorific value, so when they are burned, they give a good amount of heat. They are also used in the manufacturing of chemicals such as chloroform. We have seen that how chlorine, when added, 3 chlorines are added to methane, it becomes chloroform. So carbon black, yeah, by not complete deoxidation oxidation proper नहीं करेंगे तो definitely it is going to become a carbon black. Formaldehyde, methanol, ethanol, so which are used in rubbers, solvent for rubbers, wax, also in anesthesia. The chloroform is an anesthesia. The carbon black is black pigment in shoe polishes and printer inks, etc. The formaldehyde is an antiseptic, preventive for biological specimens, and methanol, solvent for varnish, antifreeze for automobile, and finally ethanol is solvent for resins, low freezing liquid in thermometers. So these are the different uses of methane and ethane, that is alkanes. So that was about the alkanes, and now what we see will be alkenes. So we'll start with the alkenes now. So next what we have is alkenes. Now alkenes, we very well know, are the unsaturated hydrocarbon with double bond, and hence the reaction will be addition reaction. So these are something which is very important to understand. So alkenes, unsaturated aliphatic hydrocarbons, contain a carbon-carbon double bond. So there will be a carbon-carbon double bond between the atoms of the carbon over there in their molecules. Hydrocarbons in which valency of at least 2 carbon atoms is not fully satisfied by hydrogen atoms and are deficient in hydrogen as compared to alkanes are said to be unsaturated. So because they are deficient of hydrogen, why they are deficient of hydrogen? Because उन लोगों को हाइड्रोजन इतना नहीं मिला कि इसीलिए कार्बन को एक दूसरे के साथ में डबल बॉन्ड बनाना पड़ा. So that's why it is going to be as insufficient number of hydrogen present in it, causing the carbon to share electrons with itself, forming double bond of carbon. Alkanes are known as olefins, that is oleum is oil and fins to make, so that's why it is the one which is used for making oils, so that's why they are called as olefins. They have a tendency to form oily products for treatment with when on treatment with halogens. So when these olefins, then when these alkenes are going to be treated with chlorine, it is, or bromine or fluorine or iodine, it is going to form into oily substances. That's why they are called as olefins. General formula is 2NH2N. So the general formula is 2CNH2N. So that is the general formula of this particular alkenes. Alkenes have 2 hydrogen atoms less than the corresponding alkanes, which has the general formula CnH2n plus 2. There are no alkenes corresponding to methane. So the first homologous compound of the alkenes is not methane, it is ethene. So the first one is ethene because there cannot be a carbon, single carbon cannot be sharing 2 electrons with hydrogen, and that's why the first one itself will be ethene, which is C2H4. So this is ethene, which is going to be the first product or the first compound of the homologous series of alkenes. Hence the first member of the alkene series is ethene, ethylene, C2H4, that is CH2CH2, which correspond to the alkane ethane, that is CH6, that is CH3, single bond CH3. Reactivity of alkenes. Alkenes are more reactive than alkanes due to the presence of double bond, that is carbon-carbon double bond, or called as olefinic bond. So there will be an olefinic bond which is there, which is easy to break. It is very easy to break this double bond, and that's the reason they are very active. They are very reactive in nature. That's why they are going to be, as reactivity will be much more than an alkane. Sources of alkane. Distribution wise, alkane seldom occurs freely in nature. Though ethylene occurs naturally in small quantity in plants. In the coordination of chemical coordination of plants, we have learned that ethylene is one of the product which is helping in the fruits, ripening of the fruit. So that ethylene is the same as this ethene which is present in plants. So in small quantities it is present in the plants for the maturation of the fruit or the ripening of the fruit. So that is ethylene or the ethene. The main sources, alkenes, are however produced in large amounts during thermal cracking of petroleum hydrocarbons. So we have learned about pyrolysis. So that's the thing, that when thermal cracking of the hydrocarbons take place, at that time the possibility of formation of alkenes are there. So that's why most of the alkenes are produced in large quantity when there is a thermal cracking of the petroleum products. Nomenclature wise, alkenes, there are two main ways of naming the alkenes. One is the common name. Common name will be the one which is the name of alkenes are derived from the corresponding alkanes by changing the suffix ane to ylne. So common name में हम लोग ethene नहीं बोलेंगे, ethylene बोलेंगे, propylene बोलेंगे. So it will be like this. It will not be ethene. It will be called as ETHYLENE. So instead of ENE, it will be YLENE, which is in common name. So this is common name. But of course, you are going to use the IUPAC name. So IUPAC name definitely is going to be the ethene. So common name is ethylene. The IUPAC name system, the name of the alkenes are derived from the corresponding alkanes by changing the suffix ane to ene. So ethane becomes ethene. So accordingly, you have the first one to be as ethylene or ethene, that is C2H4. Then propylene or propene with the C3H6, or butyl, the C4H8. You will find that the butyl, once you have this particular thing, they will be having their isomers. So there will be isomers over there, which could be either one butylene or it will be two butylene. Why it is so? Because one butene or two butene, because the double bond can be on the first carbon atom or it can be on the second carbon atom. So when I am having over here of anything with butylene, so butyl is 4. So it could be the double bond could be here, then it is one butylene. If it is not here but here, then it is 2 butylene. So that's why this will be 2 butene or butene, or if it is here, then it will be the first के यहाँ पे रहेगा, तो it will be but 1ene. So depending upon where the double bond is here or here, you are going to have the two isomers of this particular thing. So there are the isomers, and if it is pentane, then there will be 3 of them, then neopentane and all will be there. So that's why it will be pentene, 1 pentene or 2 pentene, depending upon where the double bond is. Now structural formula of ethene will be again the same thing, C Lia or C, and then double bond with C, and then 1 H here and 1 H here, 1 H here and 1 H here. So this is the ethene. वही अगर हम लोग ने उसको डॉट एंड x में कर दिया, तो we take the x to be as carbon, so x are carbon. So these are the carbon atoms over here. Here 2 are going to be combined here, and hydrogen ke dots are going to come here like this. So this is going to be the structural formula or the ionic formula or electronic structure of the ethene. So that's about the ethene structure and the details. We now move on to the preparation of ethene, but in the next video.